Bismillahirrahmanirrahim. This is me, Miss Aisha Manzoor, and you all are watching my channel Chemistry Solutions. So today in this lesson we are going to attempt all of the contents of your syllabus from electrolysis. So in electrolysis, electrochemistry part 4.1 is electrolysis. Define electrolysis as the decomposition of an ionic compound when molten in aqueous. But here what they are going to give us, they are giving us the definition of electrolysis, which you all have to memorize accordingly. The decomposition of an ionic compound when molten or in aqueous solution by the passage of an electric current. So you have to memorize the definition accordingly. If the meaning of this definition is, if we have any ionic compound in electrolyte form, meaning in molten or aqueous state, what will happen in that case? We use this is for example, an ionic compound in molten state. So in molten state, what will happen when an electric current is passed through this NaCl in an electrolytic cell? It convert into sodium metal and chlorine gas. So sodium chloride is going to sodium ions, it will present in ionic form as an electrolyte. So these ion will convert into sodium and chlorine. So look at the definition. The decomposition of an ionic compound. So this one is the ionic compound. So decomposition of ionic compounds tells us when molten or in aqueous solution. So why we use the molten form and aqueous form? Because in molten or aqueous form, these the ionic compounds have mobile, free moving ions to conduct electricity. So sodium ion will convert into sodium metal and chloride ion will move towards the anode and become chlorine gas. So chlorine and sodium will be the product. So decomposition of an ionic compound by the passage of an electric current. So electric current will pass through it and it will decompose the compound into its elements. Now I will tell you how to identify the simple electrolytic cell. If we talk about the simple electrolytic cell, the anode as the positive electrode, cathode as the negative, and about the electrolyte as the molten or aqueous substance that undergoes electrolysis. Describe the transfer of charge during electrolysis to include the movement of electrons in the external circuit, the loss or gain of electrons at the electrodes, the movement of ions in the electrolyte. So we will do the formation of electrolytic cell right now. Then identify the products formed at the electrodes and describe the observation made during the electrolysis. So we will do the examples of lead to bromide, concentrated aqueous sodium chloride and dilute sulfuric acid using inert electrodes made of platinum or carbon graphite. And then in the fifth point, identify the products formed at the electrodes and describe the observations made during the electrolysis of aqueous copper 2 sulfate using inert carbon graphite electrodes and when using copper electrodes. So these are the parts. So let's move towards our understanding of this topic of electrolysis. So in the electrolysis, first of all, I am going to draw the electrolytic cell. What electrolytic cell tells us? This is basically in electrolysis, basically this one is the anode, battery. This is a symbol for battery. Positive terminal connected with this carbon electrode, it will become positive, and it will become negative because negative terminal is attached with it. So then after that we will write the name of this one is the anode, and the negative terminal is called as the cathode. So electrolyte is present in it. This is the electrolyte. In electrolyte, ions are responsible to conduct electricity. So ions are there, whereas this one is the metal, wire, and called as the electrical conductor. This one is called as the electrical conductor. In metals delocalized, electrons are responsible to conduct electricity. So this one is the electrical conductor. What happens? I generally tell it to you about the things. What happens with the substances when we talk about the different ions? All, for example, we have molten NaCl. Let me take the example of molten NaCl. So ions present in molten NaCl are Na positive and Cl negative. All positive ions will move towards the cathode. So this one is the negative electrode. Oppositely charged electrodes attracted the opposite ions towards itself, whereas the all chloride ions will move towards the anode. So negative ions in the chloride ion is basically the electron. This anode will pull the electron from chlorine atom. So electron will start moving like this. So direction will be from anode to cathode. Push the electrons towards the cathode. So if we talk about the reactions at anode and cathode, how we are going to do this? At anode, chloride ion will go. One chlorine atom will lose its one electron. And overall, this Cl atom is not stable in this form because these are the halogens, and halogens exist as diatomic form. Di means two, in forms of two chloride ions now form 2Cl2. So this is the diatomic form. This is actually the reaction which you all have to memorize. Okay, so this is a reaction which you all have to memorize right now. So one thing you all must remember, the word oil. Oxidation is loss of electron. Oxidation is loss of electron. So which type of reaction is it? Because loss of electron is there, so chloride ions are moving towards, converted into chlorine. By losing electrons, so chloride ions will be oxidized. Remember, ions will be oxidized. Chloride ions will be oxidized or have been oxidized to chlorine molecule by losing electrons, by the loss of electrons. Okay, so this is the oxidation process. Now if we talk about the cathode, at cathode we have, this one is the negatively charged electrode. All positive ions will move towards it. Na plus 1 plus need 1 electron, but if it will take 2 electron, it will become like sodium metal, 2 sodium metal atoms if you are balancing the equations. Otherwise, if you will write like this, it will also acceptable and you will score mark of it. So this is a reaction at cathode. So remember the word rig. Rig is basically the reduction is gain in electron. So reduction is gain in electron. You can remember the word like rack, reduction at cathode. So rack is a word says reduction at cathode. So now this is the electrolytic cell. So let me check what kind of examples are given in your syllabus, and you have to do first of all molten PbCl2, lead chloride. This one is our electrolyte, and ions in it are lead Pb2 plus, and they have the ions 2Cl minus. So these are two ions which are present in molten PbCl2. So at anode is a positively charged electrode. Negative ions will be attracted towards it. So two chloride ions will move at anode. It will become chlorine by losing the electron. So oxidation will take place here. Then after that, at cathode, positive ions will move and it will take two electrons and become lead metal. So at cathode it will be like this. So if we will write the overall reaction of it, these electrons will be cancelled out and overall reaction of it is Pb2 ions plus 2Cl minus. It will convert it into Cl2 plus lead. So this is the overall reaction which will take place when electrolysis of molten lead chloride will be taken place. So if we have if we will have a look on the syllabus, the movement of electron in the external circuit, the loss or gain of electrons at the electrode, the movement of ions in the electrolyte, we have done it. Molten lead to bromide, we have done it. Now we are moving towards 4 part B, concentrated aqueous sodium chloride and dilute sulfuric acid. So here are the concept in your syllabus. In different boards they are taking the word differently, but concentrated means aqueous. In concentrated, let me check. In concentrated aqueous sodium chloride and dilute sulfuric acid. Okay. Concentrated sodium chloride. Now here is the story behind concentrated sodium chloride and rest of the ions. First of all, check what ions are present in it. Concentrated sodium chloride means it has the water in itself. Sodium chloride, H positive and OH negative. So these are the ions which are present in concentrated sodium chloride. But question is, which ions will move towards which electrode? If we have here the electrolytic cell, and if we have this anode and cathode provided with the battery, positive and negative, and we have the electrolyte, that one is the concentrated sodium chloride, NaCl. So this one is the electrolyte. So point is, which ions will move towards which electrode. Always for this, in order to get the understanding of this concept, you all must know the reactivity series. And if I will write the reactivity series here to give you a better understanding, which ion will go? Sorry. Kamal, or whatever you have the way to memorize this reactivity series. Kamal never calls me at zoo. Full 2 plus or 3 plus any ion, Fe3 or 2 plus. Public has come to say hi, assalamu alaikum, UPT. But now this is the reactivity series for the positive ions. If we talk about these ions which are above the hydrogen ion, will not be discharged if hydrogen ion is there. So if hydrogen ion will there, above any metal ion will not discharge. Ease of discharge increases down the group. So whatever the ion will be below these positive ions or cations are the positive ions, whatever the ions at the below of this reactivity series will discharge. Okay, so hydrogen ion will discharge instead of sodium, whereas we have another reactivity series of for the negative ions, that are anions. सुनो कल बारिश आई. Oh, so give your full attention towards it when and how we are going to select the ion. If we have ion Na1 plus, so we have selected hydrogen ion. The story behind, because hydrogen ion is less reactive than sodium, so that's why it will discharge. Discharge mean it will take up the electron and become the stable element. Now become the atom. It will convert into hydrogen gas. Then what will happen? These ions will never ever discharge. Okay, these ions will never discharge. No story is left behind. Whenever the word aqueous concentrated is there, then only halide ions will go. These ions, इनमें से which you have in your question, you have to get these ions. So this hydroxide ion will only go along with the dilute electrolytes. If the word dilute is there, then we will use the word OH minus, otherwise not. So we have NaCl, these ions. So we have decided sodium by having a look on this reactivity series, because sodium ion is very reactive, so it will not discharge. Hydrogen ion will discharge over there. Now whereas the chloride ions will discharge instead of hydroxide ions, because we have the concentrated solution. For concentrated solutions, these halide ions will discharge. So we will take up any halide ion which we'll have in our question. Dilute will always go along with the hydroxide ions. So for this sodium and chloride, now for concentrated NaCl, reaction at anode and reaction at cathode. And anode, negative ions will go, and that will be in concentrated chloride ions will go. Set, memorize the reaction. Loss of electron is there, oxidation is there. Whereas reaction at cathode, hydrogen ions will go and will take up the electrons and will become hydrogen gas. So if you can see the observation, you can see for the colorless gas, bubbles of colorless gas, or you can see the fizzing. So you all must remember the colors of the halogens, the gases of halogens. You know that fluorine and chlorine is not will be the part of it. So chlorine will be there. So you must know what is the color of chlorine gas. So observation means what you people see with your eyes are basically the observation. Okay. So yellow-green color, chlorine is of yellow-green color. Yellow-green color is of chlorine gas, whereas hydrogen is a colorless gas. For colorless gas, we use the word fizzing. Okay. Now move on. We are moving towards our next part, that is the dilute sulfuric acid. So for dilute sulfuric acid, the word dilute comes here. First of all, we check which ions we have. H positive, 2H positive and sulfate ions. These are the ions present in the acid, in water. So H positive and OH negative. So there is not a hard and fast rule. You must know that with dilute, hydroxide ions will discharge. So at anode, hydroxide ions will move, and it will gives us 2H2O plus O2 plus 4E. So these are the hydroxide ions which will move towards water and oxygen by the loss of 4 electrons. So these are the at anode, and come towards at cathode. We have no competition at cathode. Only hydrogen ions are present. So we will take 4 hydrogen ions to balance this equation to give it 4 electron, and it will become 2H2. So these are the reactions which you all will learn for the dilute sulfuric acid. Look at the rule behind this, that look at the ions which we have, look at the reactivity series, and check which ion will move first. Now we have to move on towards the electrolysis of copper sulfate by using inert electrodes and by using copper electrodes. So there are two things. If I will draw a line here, this one is a beaker, and we have the electrodes, and we have the wire, battery. Okay, this one is our anode, positively charged electrode, cathode, negatively charged electrode. Okay, anode and cathode. So all of it will dip into the solution. But point behind this, that the color of these electrodes are red brown, and we have taken the electrodes of copper. Here are the electrodes which we have taken are the copper electrodes, but here the electrodes are of carbon or graphite. Graphite is only the non-metal which conduct the electricity. So look at the difference between the electrodes present in this electrolytic cell in the electrolysis of aqueous copper sulfate solution. Copper sulfate solution is there. Now come towards the point. Number 1. First of all, we have to look at the ions in CuSO4. We have the ions Cu2 plus, sulfate, and we have the next ions are H positive and OH negative. Always remember, sulfate ions will never ever discharge. It will remain in the solution. Okay, you must know what solutions are remaining behind in the solution. We have to focus on that as well. So sulfate ions are there. We have to cross because it will not go. Now check the reactivity series. If you people will see the reactivity series, the copper is basically present below the hydrogen ions. So copper will discharge. We already have talked about this, that the after the losing copper will discharge because it is below in the reactivity series. Hydrogen ions are more reactive than copper, so copper ion will discharge, whereas hydroxide ions will go. So remaining are the concentration of sulfuric acid will becoming high when hydroxide ions will moving towards the electrodes and becoming into the oxygen and water. Product for the hydroxide ions are there. Now come towards the at anode. Look at the products. 4OH minus gives us 2H2O, water and oxygen, along with the loss of 4 electrons. So you all must remember and memorize it. Now come towards at cathode. Copper ions will go and will take up the electrons and gives us copper metal. You can balance it. 2 copper ions will take 4 electrons to become 2 copper metals. So this is the reaction while we are using inert electrodes. So this was the story of inert electrodes. Copper ions have the color of blue. Blue color is of copper ion, whereas copper metal has the color red brown. So for red brown color, which will deposit at the cathode, the mass of cathode also increases because of the deposition of the metal at this electrode. So blue color of ion will convert it into red brown metal. But if we have the electrodes that are copper electrodes, along with copper electrodes, if we have the copper electrode here, instead of taking up the electrons from the solution, this one is not the inert electrode. It will taken up its electron from this metal. The size of this anode will start decreasing and size of this metal will start increasing. Why? Because at anode will start dissolving this copper electrode, and this one is the anode, whereas here connected with the negative terminal of the battery. So this is the again copper electrode. At anode, copper metal will lose its electrons to become copper ion, and constantly it is giving away copper ions in the solution. If it is moving in, copper ions will taken up the let me write the another equation at cathode. If copper ions are taken up the electrons and become reduced to copper metal, that is red brown color. The red brown color also deposit here, all of the metal deposit here. Okay, so the mass of the cathode increases and the mass of the anode decreases. Why? Because copper is not the inert electrode, so at anode it will lose its electrons and become oxidized. Copper metal will become oxidized. So the color of solution will not be decolorizes with the passage of time. The color of solution will remain blue. Why? Because anode producing the copper ions as the process going on. Copper ions if used up, then constantly copper metal is producing copper ions. The color of solution will not be fade. Whereas as the observation, if you will see color of solution in because all the copper ions are taken up, so converted into copper metals, all the copper ions are going towards the cathode and taken up the electrons to become copper metal. So this is the part which we have done of the electrolysis. Now we will see the So we have done, when using copper electrodes, we have done the electrolysis of it as well. So next is state the metals or hydrogen are formed at the cathode and not that non-metals other than hydrogen are formed at the anode. So you all must know that the metals, basically the point is the metals or hydrogen are formed at the cathode. So cathode is the negatively charged electrode. Metal ions will move towards here, like we have done. Sodium ion went over there, and about the lead ions or hydrogen ions. So metal and hydrogen ions are formed at the cathode, and that non-metals are formed at the anode. So chlorine or iodine, if we have the respective compounds, and oxygens, non-metal form at the anode. Predict the, because as you know, non-metals are negatively charged elements, it moves towards the positive electrode, that is our anode is a positive electrode, so it moves towards it. Predict the identity of the products at each electrode for the electrolysis of a binary compound in the molten state. So all of you must know, if aqueous sodium chloride is moving towards the aqueous sodium chloride or our molten sodium chloride, in molten state which compounds will form. We have done it molten lead chloride. If we are talking about the sodium chloride, then sodium and chlorine will produce in the sodium and chlorine will be the product. So predict the identity of the products at each electrode for the electrolysis of halide compounds. So any one of the halide or dilute or concentrated solutions are there. The point which you all must remember, that halide compounds always formed when concentrated solution is there or molten solutions are there. With dilute, hydroxide ions will move or discharge in the electrode, that is anode, and it will form oxygen and water will be the product. Okay, so construct half equation for the reaction at anode. You all know that where oxidation is taking place or not, we have done it right now. State that metal objects are electroplated to improve their appearance and resistance to corrosion. Describe how metals are electroplated. So this is the point which we haven't done. Now move on towards the electroplating. Now, electroplating. If question is there that do the silver plating on jug and draw the diagram. So we have to do the silver plating. Silver has charge 1 plus. You all must remember the charges on the electrodes. So the principle behind electroplating is one metal is going to plate with another metal, or one object is going to plate with another with the metal. For example, we have to make a jug. Okay, we have to make a jug and we have to plate it with silver. For this purpose, what we will do, we will take the silver here. Let me take the another color which will resemble to silver. Okay. No white color is there. Okay. I will take the yellow one. If I will take it as a silver, this is not the silver color. The color of silver will be like this. Okay. The color of silver. Okay. This is a silver metal. Okay. Now we will move on. I will connect this silver metal with the positive terminal of the battery and connect the object to be plated will be connected with the negative terminal of the battery. So silver will become anode and this jug will become a cathode. Now you all must remember that the anode are the positively charged electrodes and cathode are the negatively charged electrode. First we will make the anode which we have to plate, then the object to be plated will be making the cathode. We will dip it in the solution, that will be our silver nitrate. So soluble salt of this we have made this silver metal. So silver metal. So we will take the soluble salt of that matter. If we are going to plate chromium, we will take chromium nitrate. If we are going to plate gold, we will take gold nitrate. If we are going to plate nickel, then we will take nickel nitrate. So all electrolyte will be aqueous or dilute silver nitrate. Object to be plated will be cathode. We will make the jug with the plating of it. Then we will make the silver, we will take the silver metal. So silver is basically what will happen at anode and what will be happening at cathode. We will write the half equation here, okay? So now take this. At anode, silver metal is not an inert electrode, so it will lose its electron to become silver ion by losing one electron. Whereas at cathode, no nitrate ions will go. As you know, the ions are there, silver ions. Let me write the ions of it. I will show you which ions are present in this electrolyte. Silver ion and hydrogen ions. Silver ions below the hydrogen ions in the reactivity series. So silver ion will go at the cathode and taken up one electron and will become silver metal. So slowly, with the passage of time, the silver metal will get deposit at this jug. Let me take the color. No white color. Okay, I will take this color here. This jug will start to electroplate like silver metal with the passage of time. So this one is the jug which is plated with silver. So silver plating is done by doing this experiment. So this is the end of this part. The next part we will do right short after few minutes. That is the hydrogen oxygen fuel cell. So in second part we will find the hydrogen oxygen fuel cell. So signing off, Miss Aisha Manzoor. So this is the end of this part. In second part we will do the hydrogen oxygen fuel cell. So signing off, Miss Aisha Manzoor.